Millennium to power millennium. Good morning, namaskar. This is Suraj Singh speaking from Bharat, India on this day, April 19, 2022, Tuesday, and this is 3:17 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ. आज तारीख दिनांक 19 अप्रैल. Only way projects works, designs, contracts, reliable engineers, power of communication, concrete specifications, civil engineering, safety, health, environment, methods, disputed claims, what we do. Topic is very clear. You can note down my email ID, that is suraj_engineer engineer @yahoo.co.uk. suraj_engineer@yahoo.co.uk. And this is my identification, public identification. I am member of Institution of Engineers, FIE. FIE means Fellow of Institution of Engineers, by virtue of which I am Chartered Engineer India, Bharat ka Chartered Engineer, and also I am additionally qualified as International Professional Engineer India, as well as specifically I am Certified Arbitration Engineer, empaneled by Institution of Engineers India, and I belong to Civil Engineering Division, Civil Engineering branch. This is my certificate of arbitration engineer, and this is International Professional Engineer certificate. This is Chartered Engineer certificate. This is quality file, and this is coordination file. I close Chartered Engineer certificate and I close arbitration engineer certificate. I'll open if it's required. And now we go to quality file. Quality, which is my essence of this talk. It's not new, it has been for long. For me, quality is life. You have life. If it is quality less, you have no life, frankly speaking. People think money is life. Some people think spiritualism life. Some people think good living is life or art of living is life. But nobody talks of requirement of quality, and that's unfortunate. People are not interested in quality of life. Quality of life means what we do, what is our contribution to make something good and then better and this best. Do we? My answer is that no. And particularly in our country, that is Bharat, India, we have to question ourselves for quality issue and also for coordination issue. Digital world has destroyed coordination. To be very frank, I can openly and frankly with full confidence state quality cannot be achieved without application of required coordination, and coordination can be affected only if we know what information is involved or are involved. Whatever we do in profession, without availability of information, required information, no work can be done. And every work has many facets. Every work. It's not simply that I state coordination is done. Coordination is not done automatically. Coordination is done based on available information as well as whatever else is required. And whatever is required, only an experienced person knows. Everybody cannot know. Who have experienced those people, who don't have experience, those people, Both have different performance relief. A person who has experience, he knows what should be required, what is deficiency, what's deficiency in that, what information is necessary, or what information can be, you can say, extracted later on also. But a person who has no experience, that person does not understand anything as far as coordination is concerned. This means coordination learning is significant activity. To achieve quality, we require product quality. We require product availability. And we can say this product is quality one. Quality is not an item, it's not an object. It is a part of object. Without quality, if we produce, that object is nothing. That object is useless. Because performance depends on whatever quality has been included with that product. And quality means certain parameters, agreed parameters, approved parameters, or intended parameters one should have. We can learn it from many angles, many aspects, but we are talking of engineering, we are talking of development, we talk of advancement, we talk of every branch of world engineering. Whole world advances because of sciences and engineering. Particular development, physical development, infrastructure development of every country depends on engineering advancement, engineering technology. And nothing is now single. Every work has many branches of engineering involved. Whatever a person or engineer works, that person must have some, you can say, inroads pertinent, different branches of engineering. Suppose a person, an engineer, designs a building, a structure, and its complete activity performance, one has to deal with many services branches of engineering like mechanical, electrical, HVAC, CCTV, firefighting, water supply, plumbing, structures, and many more. These requirements are mandatory nowadays. We have to know everything about what services building must have. And if you don't know that, there is no way that we will be successful in designs of building and post-design in construction of building, particularly buildings which are involved everywhere. And buildings means other structures also, which are not that much complicated like buildings, but still these are part of infrastructure. It can be whatever way you can say. It would be water supply, it would be drainage, it would be stormwater drainage, it would be plants facilities, it would be other structures like hospitals, it would be airports, it would be, you can say, part of development. Every requirement, or you can say every infrastructure project has got, according to its functioning, various input. It requires various inputs from services branches, and those inputs must be known before these are put into design, and design must be coordinated properly. But that type of professionals are not available everywhere. Reason being, coordination is not a subject yet. Quality is not a subject yet. There are quality assurance engineers, but I say quality assurance is not sufficient. Quality requirement is real requirement. Coordination is real coordination. Maybe in future we shall have such subjects as coordination, because experience moves on, and those who have got lot of experience in field, they should work on this, including myself. That's why I decided to start this type of talk for whole world. It's not only for engineers, but for whole world. because coordination is coordination, and this fact cannot be denied. Without coordination, life does not move, and that is also a fact. We have to keep ourselves awakened, not sleeping, if we want to achieve something. In this regard, coordination is very important, and that is engineering coordination, that is for projects, for public, and we can say reliable quality engineering works deliveries is must. Same way, reliable coordination engineering is a must. Quality engineering is a must. Professional engineering, of course, constitutes both. And in addition to these subsidiaries, it requires primary materials, primary technology, and missing real coordination means missing good engineering. There are so many issues involved in this, and we have to be very serious about that. Now I'm just moving on to file of concrete, because that is important item, concrete, which is, we may say, our real requirement, and we talk of we were yesterday somewhere, and it was mass concrete. I'll start from that, because mass concrete is a very important item, and its journal is mass concrete. We did it yesterday, but because of disconnection of video, we could not continue it. So I'm just moving back to page 228 of mass concrete or massive block concrete. In cases where thermal stress due to heat generated by hydration of cement, in cases where thermal stress due to heat generated by hydration of cement is problematic, concrete is regarded as mass concrete, and measures to be shall be carefully determined. Mass concrete verification concerning thermal stress and thermal cracking due to heat generated by hydration of cement shall be performed in advance in accordance with design general requirements. It shall be ascertained prior to commencement of construction that conditions assumed in design section of this specification agree with actual construction conditions. If conditions assumed in design section do not agree with actual construction, if conditions assumed in design section do not agree with actual construction conditions, verification concerning thermal stress and thermal cracking due to heat generated by hydration of cement shall be performed prior to commencement of construction on basis of actual construction conditions. I repeat, it shall be ascertained prior to commencement of construction that conditions assumed in design section of this specification agree with actual construction conditions. If conditions assumed in design section do not agree with actual construction conditions, verification concerning thermal stress and thermal cracking due to heat generated by hydration of cement should be performed prior to commencement of construction on basis of actual construction conditions. Prior to mass concrete construction, appropriate plans for concrete temperature control, transportation control, placement control, curing control, etc. shall be made so that effects of thermal crack control measures determined in advance can be achieved. So these are many controls we should think of again and again, and these are temperature control, that's plan for temperature control. That's very important when fresh concrete is delivered. And transportation means transportation from mixing plant to site and from site to actual location of concrete, which is done by either crane or by pumping. And then when you received it on location, how to place it there, placing concrete on slabs or in columns or in beams or whatever else. And after doing finishing of that placement, after vibration, etc., curing, how to apply that, all these plans should be considered prior to doing mass concrete or massive block concrete. It's not easy. Every activity requires to be understood in this way, and this shall be made so that effects of thermal crack control measures determined in advance can be achieved, and that is objective of mass concrete, because temperature difference, generation of temperature itself, thermal energy in case of mass concrete is quite huge, it's quite considerable. There can be no major difference between internal part of mass block and external part. That point must be understood, and we have to study that as well. Together with recent developments in advanced construction methods, there have been increased demands for construction of large size concrete structures. Frequently observed that thermal stress which develops due to temperature variation during cement hydration process causes thermal cracking of large size concrete structures. These problems were once considered peculiar to concrete dams or concrete structures with especially large-sized members. However, harmful cracks are often recognized even in relatively small-sized structures, depending on cement materials used in construction conditions. It says harmful cracks are often recognized even in relatively small-sized structures, depending on cement materials used in construction conditions. Concrete structures which face above mentioned problems of thermal stress due to heat of hydration shall be dealt with as mass concrete, and consequently special considerations are necessary. Though it cannot be absolutely determined due to fluctuation of type of structure. It cannot be absolutely determined due to fluctuation of type of structures. Materials used in construction conditions, size of member regarded as mass concrete is roughly considered to be not less than, you can say, 80 to 100 centimeter or 1 meter. You may say 800 to 1000 mm size. You can say size of member regarded as mass concrete or thick member, you may call it. That is, generally it is 80 centimeter or 800 mm which we take in practical life. I have seen many projects about that, and size which is 80 centimeter or 800 mm or all is considered thick member, ought to be not less than, you can say, for walls it is 500 mm. If wall is 500 mm more thick, it's considered thick member or massive block. And if it is restrained at lower end, for concrete which rich mixed proportion, concrete with rich mixed proportion, as in case of Priestess concrete structures, thin members may also be included in scope of this chapter if it is Priestess concrete, depending on restraining conditions. Dam concrete is not stipulated in this chapter but in standard specification. Dam concrete. Crack controlling measures such as crack prevention, or restriction of crack position and width should be considered at each stage of design. Each stage of design, selection of materials, determination of mix proportions and construction. Selection of materials, what materials we have to select, aggregate, etc. Determination of mix proportions, that is by trial mix, and its construction. Method for evaluating effectiveness of each crack controlling countermeasure. Method for evaluating effectiveness of each crack controlling countermeasure by quantitatively estimating influence of these measures on development of thermal crack at various stages has been almost established from recent researches. Verification for thermal crack in construction of mass concrete should be carried out in advance by following. Block concrete, where large amount of concrete is included continuously in order to satisfy desired concrete quality. It is especially important that all processes of production, supply, transportation and compaction of concrete are controlled completely based on construction plans. So we have again to go back to process of production, supply, transportation and compaction of concrete, which all require controls, complete professional controls. That's why I always stress on method statements, construction procedures, which are very significant before doing whatever job we do. And if we don't do that, this means we do in blind world. During construction of mass concrete, so structures concrete may be delivered from several ready-mix concrete plants. As a general rule, cement and chemical admixture produced by same manufacturer, coarse and fine aggregates produced from same region should be used when possible. When materials differ for each ready-mix concrete plant, trial mix should be considered. It should be carried out in advance in order to confirm safety of, or you can say without impact, mixing before construction. When using chemical admixture, great attention is required because incompatibility between chemical admixture may be observed. Now, as a general rule, a verification of performed concerning initial cracking. As a general rule, verification be performed concerning initial cracking. Same chapter also requires that a limit for crack width be set if cracking is to be prevented or permitted. Although design section assumes construction conditions for purposes of design studies, actual construction conditions such as weather conditions, air temperature, wind speed may change considerably prior to commencement of construction. It must be checked whether or not presumed conditions agree with actual construction conditions. If pre-assumed conditions have turned out to differ from actual construction conditions and study results based on design section requires to be modified, studies must be conducted again before starting construction by method specified in design section. In controlling thermal cracking during massive block concrete pouring construction, various measures for preventing cracking, controlling position, interval and width of cracks should be carried out in construction stage in order to satisfy required function and performance of structure. In order to control thermal cracking, not only selection of cement type materials, admixtures, mixed proportions, as well as adjustment of concrete placing temperature, but also selection of formwork dimension, lift height, joint position, placing time, interval, material and fabrication of formwork, as well as curing method should be considered thoroughly from production to construction stages. In order to control thermal cracking, what we have to do? Not only selection of cement type, of course that's one point. It's not only selection of cement type, materials, admixtures, mixed proportions, as well as adjustment of concrete placing temperature, but also we have to think of selection of formwork dimensions, dimension of formwork, what is height of concrete lift, where is joint, construction joint or the joints, placing time interval, how many hours it shall take, and where should be gap, material and fabrication of formwork, as well as curing method. Consideration must be given, and that should be thoroughly from production to construction stages. Depending on structure type, controlling crack position by crack inducing joints may be effective in some cases. Regarding these measures in making concrete and construction, for controlling and preventing cracking, construction of mass concrete should in general be carried out in accordance with standard specification. Designs in which requirements on material, mix proportion, production and construction methods are described in details. It is based on prior examination related to thermal cracking. Other methods of controlling, other methods of controlling or preventing thermal cracking, such as using pipe cooling for dam, concrete or large bridge pier, using expensive concrete or arranging reinforcing bars for crack control can be adopted. However, what about materials? Cement and admixture used in mass block concrete should be one specified in design, and if cement or admixtures mentioned are to be used, verification concerning thermal stress and thermal cracking due to heat generated by hydration of cement shall be performed. Cement and admixtures used in mass concrete must be selected after verification concerning thermal stress and thermal cracking due to heat generated by hydration of cement. Specification requires the cement be selected on basis of verification concerning thermal stress and thermal cracking. Since, however, actual construction conditions can't always be predicted at design stage, there could be cases where prior to commencement of construction, cement and other materials are reconsidered and selected again through similar verification. In case of mass concrete, or generally it's written mass concrete, so massive concrete should say. In case of massive concrete, quality of cement greatly affects strength of concrete, heat generated by hydration when selecting cement to be used in mass concrete. Therefore, it is necessary to thoroughly study characteristics of different types of cement and select cement appropriately so that concrete of required quality can be obtained. In general, it is desirable that low heat cement such as moderate heat Portland cement, low heat Portland cement, blast furnace slag cement and fly ash cement be used. When selecting cement, it should be kept in mind that generation of heat by blast furnaces like cement tends to be accelerated as temperature rises. In cases where blended cement made by mixing Portland cement with relatively large quantities of admixtures such as ground granulated blast furnace slag and fly ash is used, quality and properties of such blended cement often vary considerably among manufacturers. When using such cement, therefore, it is necessary to fully identify its quality and properties in advance by, for example, conducting tests. In general, in case of cement whose heat generation is suppressed, degree of long-term strength increase is relatively high. Compared with normal Portland cement, when using such cement, therefore, it's good practice to check Stresses that occur in member during period until specified strength is reached, and use of relatively old age around 91 days as a reference age at which specified strength is determined. Admixture commonly used for massive block concrete include mineral one such as fly ash, GGBS, or we can say ground granulated blast furnace slag, and chemical admixtures such as air entraining agents, water reducing agents, air entraining water reducing agents, and air entraining high range water reducing agents. Use of expensive admixtures has been increased in recent projects. Use of high quality fly ash brings about a number of beneficial effects such as improving workability of concrete, reducing water content, increasing old age strength development, and reducing temperature rise due to heat of hydration of concrete. Fly ash therefore is advantageous for purpose of controlling occurrence of cracking due to thermal stress. Furthermore, appropriate use of fine grained blast furnace slag powder makes it possible not only to increase long term strength of concrete but also to slow down generation of heat due to hydration. Appropriate use of air entraining agents, water reducing agents, all entraining water reducing agents or air entraining high range water reducing agents makes it possible to improve workability of concrete, reduce water content and thereby reduce cement content. By using all these admixtures, amount of rise in concrete temperature can be reduced. If a large volume of mass concrete is to be placed, recommendation is that retarder type water reducing agents or air entraining water reducing agents be used to lower rate of generation of a heat of hydration and prevent occurrence of cold joints. In such cases, however, setting may be retarded considerably depending on such factors as combination with mineral admixtures to be used and air temperature during construction. It is therefore important to check in advance on degree of retardation of concrete setting and influence of strength development characteristics by means of tests. Mixed proportion as basic rule, cement content of mass concrete should be as specified at design stage. If it's not possible to achieve required workability, strength, durability, water tightness, cracking resistance, or steel protection performance with cement content specified at design stage, or if type of cement or admixture to be used has been changed, verification concerning thermal stress and thermal cracking shall be conducted again and cement content determined accordingly. Rate of heat generation of concrete is roughly proportional to cement content, and in general concrete temperature increases or decreases by about 1 degree Celsius for every 10 kg per meter cube of increase in cement quantity. A substantial increase in cement content determined as a result of verification concerning thermal stress and thermal cracking must be avoided. If however it is difficult to achieve required workability, strength, durability, water tightness, cracking resistance, or steel protection performance with cement content specified at design stage, it may be necessary to reconsider cement content if type of cement or admixture to be used is changed. It is necessary to perform verification concerning thermal stress and thermal cracking Again, determine a cement content or a binder content if non-cement binder is used or included. That doesn't cause any problem associated with thermal cracking. So here point is 1 degree Celsius means if you use 10 kilogram per meter cube more cement, 1 degree Celsius is increased, and we generally take 32 or 35 degrees. This means 300 kilogram cement can give you about this 32. And production, mass concrete shall be produced. Mass concrete shall be produced. Mass concrete shall be produced taking into consideration such factors as transportation distance, transportation methods, placing methods, weather conditions, and other conditions, so that placing temperature does not exceed specified limit. Lowering concrete placing temperature is effective in thermal stress. Lowering concrete placing temperature is effective in thermal stress. Thermal cracking because thermal stress and thermal cracking because doing so reduces difference between temperature in member and temperature outside member and lowers highest temperature in member. One method of lowering temperature, placing temperature, is pre-cooling, in which ingredients such as water and aggregate are cooled in advance when concrete is produced. Effect of temperature of each material on as mixed temperature of concrete is follows: a change of plus minus 2 degrees Celsius in aggregate temperature results in change of plus minus 1 degree Celsius in mixed temperature. Change of plus minus 4 degrees Celsius in water temperature resulting in change of plus minus 1 degree Celsius, and change of plus minus 8 degrees Celsius in cement temperature resulting in a change of plus minus 1 degree Celsius. So the three conditions: one is change of plus minus 2 degrees Celsius aggregate results in half of plus minus 1 degrees Celsius in mixed temperature, and change of plus minus 4 degrees in water temperature. 2 degrees was aggregate temperature and 4 degrees is water temperature, results in change of plus minus 1 degree Celsius, and change of plus minus 8 degrees in cement temperature resulting in 1 degree Celsius. So aggregate changes 2% for 1 degree Celsius. 2 degrees Celsius change in aggregate means 1 degrees change in mixed temperature. And same way plus minus 4 degrees Celsius in water temperature means water temperature, it also results in plus minus 1 degree Celsius of cells, and then 8 degrees Celsius in cement temperature, again point plus minus 1. So we can say aggregate 2 degrees change temperature of aggregate 2 degrees, water is 4 degrees, and 8 degrees in cement temperature. We have to keep this point in mind. Means if there is a change on plus minus 2 degrees in aggregate, or there is plus minus 4 degrees in water, and is plus minus 8 degrees in cement temperature, then this is plus minus 1 degrees concrete temperature. Pre-cooling methods include a method that uses cold water, a method that uses flake ice or small ice fragments independently or in combination as part of mixing water, a method that uses cooled aggregate, and a method that cools materials or concrete by using liquid nitrogen. If small ice fragments are used as part of mixing water, it must be ascertained before placement of concrete that ice has completely melted. If liquid nitrogen is used for cooling, care needs to be taken to ensure safety, particularly in control of concentration of oxygen, and in round place where liquid nitrogen is used. If liquid nitrogen is used for cooling, care be taken to ensure safety particularly in control of concentration of oxygen at and around place where liquid nitrogen is used. Even if temperature of concrete at time of production is lowered, concrete temperature may rise during transportation, so that placing temperature becomes higher than expected at planning stage. It is important, therefore, to determine temperature of concrete at time of production, taking into account likely amount of rise in concrete temperature due to such factors as transportation distance, transportation methods, and weather conditions. Construction. Partitioning into blocks, lift height, and joints. In placing mass concrete, size of blocks, height of lift, location and structure of joints, and interval between successive castings should be decided based on results of thermal verification. In placing mass concrete, size of blocks, height of lift, size of blocks means area, height of lift, whatever rise we have to give, to what height we have to cast concrete, location and structure of joints, and interval between successive castings should be decided based on results of thermal verification. In mass concrete, large volume of concrete is placed. In mass concrete, you can say, large volume of concrete is placed in many blocks. In mass concrete, we may say large volume of concrete is placed in many blocks which are separated by joints. Location and structural details of joints as well as size of blocks, dimension of horizontal and vertical partitioning needs to be determined with comprehensive consideration of heat dissipation and restraining conditions as well as various construction conditions, one of which is concrete placing capacity each time. When massive block is placed into blocks partitioned vertically or into lifts divided horizontally, stresses will develop with variation of temperature. In concrete structure, because newly placed concrete is restrained by previously placed concrete, these stresses grow larger when differences in effective Young's modulus as well as temperature between new and old concrete increase. Therefore, concrete placing time interval should be kept as short as possible. However, where concrete is placed lift by lift on such bodies as rock beds, which provide significant restraint, too short placing interval may result in high temperature in mass concrete and consequently high potential of crack development. Placing interval at construction site shall be determined in due consideration, together with other measures to deal with development of thermal stress. Placing temperature of massive concrete shall not exceed plant temperature. During placing process, temperature of concrete shall be measured. Thermal history of placed concrete shall be monitored, and plan for construction may be changed accordingly if necessary. Verification method for placing temperature of mass block concrete is included in verification of thermal crack. One must keep in mind that assumed conditions at design stage of thermal characteristics of material and environmental conditions may differ from those at construction stage. When actual placing temperature exceeds assumed placing temperature, when actual placing temperature exceeds assumed placing temperature of mass concrete, prevention of thermal cracking as well as control of crack width may become difficult. As a result, desired function and performance may not be satisfied. Concrete temperature and temperature rise of placed concrete should be confirmed at time of construction. Construction plan should be modified if actual construction condition is too much different from assumed one, especially when placing concrete under scorching sun. Special care on management of materials, concrete production, transportation, placing, etc., shall be applied to make sure that actual placing temperature shall not exceed planned one. Since exothermic properties of Portland-based blast cement process like cement is accelerated, since exothermic properties of Portland blast furnace like cement is accelerated, if temperature is high, placing temperature should be as low as possible in order to control temperature rise. Curing. In curing mass concrete, appropriate care should be taken to control concrete temperature so that thermal cracks can be controlled per plan. In curing of mass concrete, adequate measures for thermal crack control In curing of mass concrete, adequate measures for thermal crack control based on results of verification and curing methods specified in construction plans are required to be taken additionally with conditions required for curing of normal concrete. Especially it is necessary to apply appropriate measures to cool down concrete temperature as close to ambient air temperature as possible to keep temperature difference between interior and exterior of concrete member. To keep temperature difference between interior and exterior of concrete member as low as possible and to maintain temperature drop rate of whole member at acceptable level. If necessary, such measures as thermal insulation and protection of concrete surface with adiabatic materials, styrol or sheet should be implemented. Sprinkle of more water that necessary may lead to formation of cracking. Sprinkle of more water than necessary may lead to formation of cracking by decrease in on surface temperature of concrete. Pipe cooling is used in order to reduce maximum internal temperature of young concrete. Pipe cooling is used in order to reduce maximum internal temperature of young concrete and overall temperature of members to average temperature of concrete structure. Pipe cooling is carried out by pumping cold water, chilled water or natural river water through pipes previously placed in concrete. In pipe cooling practice, thin-walled steel pipes of thin external diameter of approximately 25 mm are usually used. Factors such as space between pipes, water flow, and length of coil as well as cooling off duration should be determined to obtain required effect. Temperature of cooling water also should be determined by considering placing time intervals. Construction period, thickness of members, etc. If temperature of cooling water is too low, temperature difference within member or between members may cause a crack initiation. Therefore, sufficient caution requires to be taken. Temperature difference between circumference of cooling pipe and cooling water should be maintained less than 20 degrees. Temperature difference between circumference of cooling pipes and cooling water should be maintained less than 20 degrees Celsius. In pipe cooling practice, air can also be used instead of water. Mass concrete using moderate heat Portland cement, low heat Portland cement, and blast furnace slag cement requires sufficient curing with thermal insulation to obtain sufficient strength. Formwork. Material and structure of formwork for mass concrete and timing of formwork removal shall be appropriately decided so that thermal cracking can be effectively controlled. Concerning formworks for mass concrete, material and structural details are recommended to be selected with consideration of control of concrete temperature for purpose of thermal crack control. To minimize temperature rise, formwork which have high heat dissipation. Formworks which have high heat dissipation may be used. However, in case of mass concrete, control range of temperature rise is restricted and ambient temperature may drop drastically after placing. Use of exoteric metal formwork may cause large temperature difference between internal part of concrete and its surface. Sometimes use of insulated formwork is effective. When insulated formworks are used, retaining duration is prolonged in principle compared with conventional formworks, and thermal insulation of concrete surface is recommended to be continued after formwork removal by such measures as covering concrete with plastic sheets so as to protect concrete surface from rapid cooling. So important when insulated formworks are used, retaining duration is prolonged in principle compared with conventional formwork, and thermal insulation of concrete surface is recommended to be continued after formwork removal by such measures as covering concrete with plastic sheets so as to protect concrete surface from rapid cooling. Crack inducing joints. In cases when crack inducing joints are provided to control position of thermal crack, structural details and positions of these joints shall be determined as specified in design documents. Crack inducing joints. It's difficult to control thermal cracking occurring in massive wall type structures by taking measures from material or mixed design aspect. In such cases, there is this method in which reduced sections are provided at certain spacing intervals on the longitudinal direction of structure to induce cracking at these sections, to prevent cracking at other portions, and to easily take care of cracked section. Now, certain crack induced joints we have to think of. Quality control. We'll see that crack inducing joints in chapter design section 14.8. Look into that one. Now it is quality control. Quality control. Quality control, which is very significant one for execution of concrete work. For execution of concrete work, quality control be performed appropriately in all aspects of work, including concrete materials, reinforcing materials, equipment, concrete production methods, construction methods, and concrete structure until completion in order to construct a concrete structure with required quality economically. For execution of concrete work, quality control shall be performed appropriately in all aspects of work, including concrete materials, reinforcing materials, equipment, concrete production methods, construction methods, and concrete structure until completion in order to construct a concrete structure with required quality economically. Quality control is a series of voluntary activities. Quality control is a series of voluntary activities of contractor, and contractors shall develop plans of methods that contractor can expect to be effective and carry them out appropriately. Record of quality control be kept for a certain period of time even after delivery of constructed structure so that they can be used for quality assurance of constructed structure and quality control of future construction work. Progress control. Progress control, quality control, and safety control are important in concrete work. Progress control, quality control, cost control, and safety control are important in concrete work. Of these, quality control is a series of effective and organized activities performed at all stages of construction work in order to economically construct a concrete structure that matches its purpose of use. Of these, quality control is a series of effective and organized activities performed at all stages of construction work in order to economically construct a concrete structure that matches its purpose of use. Quality control requires to be performed appropriately in all aspects of work, including concrete materials, reinforcing materials, equipment, concrete production methods, construction methods, and concrete structure until completion. Quality control in production and construction may be referred to as production control and construction control respectively. A concrete structure can be made to rationally meet owners' requirements. If constructed under appropriate quality control, because owner receives a structure that has been constructed under quality control of contractor and has passed inspection. Inspection may be simplified by performing appropriate quality control. Quality control should be performed so that quality stayed in a stable condition. Quality stay in stable condition. Warning in all stages of construction work should be found as soon as possible and make an action for it. It's important to establish system contain PDCA cycle, plan, do, check, and action. It's important to establish a cycle, that is system cycle, PDFA, PDCA, plan, do, check, and act. When drawing up a quality control plan, it's important to identify a person responsible for each process and construct an organizational system for quickly responding to an abnormality. Since quality control is a series of voluntary activities performed by contractor can perform only activities that contractor deems necessary. If contractor inspects, covers all items If contractor inspection covers all items and frequency of inspection conducted by owner, measurements conducted by contractors are deemed to be equivalent to measurements conducted by owner. It is possible, therefore, to make passing owner's inspection easier by checking in advance. Design is possible, therefore, to make passing of owner's inspection easier by checking in advance design drawings and specifications, and inspection criteria, inspection plan shown by owner, and reflect them in quality control plan. And if tests are conducted as part of quality control activities associated with production and construction, it's good practice to use methods that permit objective evaluation and that are easy to understand, and methods specified for inspection purpose. For general tests, refer to test methods or other standards. It's difficult, however, to make a comprehensive judgment Hence, if tests are conducted as part of quality control activities associated with production and construction, it's good practice to use methods that permit objective evaluation and that are easy to understand, to honor and methods specified for inspection purpose. For general tests, refer to specifications. Alright. It's difficult, however, to make comprehensive judgment solely on basis of quantifiable data, such as measurement results obtained by one engineer. It's good practice to use methods that permit objective evaluation and that are easy to understand. For general tests, refer to specifications or other standards. Difficult, however, to make comprehensive judgment solely on basis of quantifiable data, such as measurement results obtained by means of tests and inspection devices. It is also important, therefore, to deploy experienced specialists and make judgments based on visual inspections. Quality control records are documents certifying that the required quality has been achieved and are also invaluable data that can be used to improve quality and prevent problems in future projects. Contractor, therefore, now quality control records are documents certifying that required quality has been achieved and also invaluable data that can be used to improve quality and prevent problems to Quality control records are documents certifying that required quality has been achieved and are also available data that can be used to improve quality and prevent problems in future. Contractor therefore has agreed and achieves. Now, contractor therefore needs to store records for certain period of time, and that's important. Quality control of concrete materials and reinforcing materials. In quality control, in quality control of concrete materials and reinforcing materials, materials shall be managed so that they meet their respective quality requirements and stay in stable condition as much as possible. In order to construct a concrete structure of required quality economically, it is necessary or needless to state that quality of concrete materials, namely cement, water, aggregate and admixtures, and reinforcing materials meet specified requirements. In addition, it is desirable that variations in quality of those materials be small. State of storage of concrete material and reinforcing material should be controlled appropriately so that their quality does not change. The state of control should also be checked periodically. Although quality of mixed admixture such as super plasticizer and quick setting admixture, quality of admixture such as super plasticizer and quick setting admixture or quality control. Although quality of admixture such as super plasticizer and quick setting admixture or reinforcing materials which is used at construction site which is used as construction site. Quality control at construction site is important for quality of aggregate when contractor produces concrete. Contractor shall test related to quality control of aggregate and shall keep storage conditions, grading of aggregate and percentage of surface moisture may be used as an index in quality control of aggregate. For instance, quality control in concrete production. In quality control in production of concrete production equipment and production processes be controlled appropriately so that concrete of required quality can be produced stably and smoothly. In production of concrete, storage facilities, measuring equipment and mixtures must be stored appropriately during production period so that requirements specified in section 5 are met. In order to continue to produce coarse concrete of stable quality, it's good practice to measure surface moisture content of aggregate. To measure surface moisture content of aggregate with moisture meters on a continuous basis, and if a considerable change or whatever abnormality in property of concrete has been observed, take aggregate samples and compare surface moisture contents. Because it is necessary to ascertain that measurement errors are small enough to stay within an allowable range. If an automatic batching recorder printer is available, records from recorder should be used to check whether measured values are stable. In mixing control, changes in quality of concrete can be identified by observing state of mixing of concrete on monitor screen and checking mixer load current. Success or failure of quality control can be evaluated by checking, for example, operation and cleaning status of production equipment deterioration and damage, and observation or by listening to sound of machines in operation. Test results such as compressive strength, slump and air content of concrete can be recognized by quality charts. Obtained data is plotted in chart with mean value, plotted in chart with mean value, upper and lower control lines. For quality control, range of control lines should be defined appropriately. When result out of range is observed, it should be investigated whether reason of change causes change of quality permanently, and a provision for it should be conducted. Control limit line be changed based on quality control data. During construction period, histogram is useful to represent distribution of quality and ratio of passed of false and margin for quality can be assessed by histograms with criteria. Shape of histogram indicates warning in construction process, quality of used material, production of concrete and testing. Quality control of concrete. Quality of fresh concrete and hardened concrete to be controlled so that concrete stable quality can be obtained. Quality of concrete in a structure is greatly affected by quality of concrete used. When controlling quality of concrete, therefore, it's important to accumulate quality control data and analyze on daily basis, so that relationship of quality of concrete with production of concrete materials and concrete can be quantified. Quality control should be conducted at appropriate period, and frequency refers to inspection standard chapter. Confirmation of mixed proportion. Mixed proportions indicated in mixed plan do not necessarily agree with mixed proportions of concrete actually produced. It is therefore recommended that production related records such as printed records be checked for comparison with actual mix proportions. Quality concrete of fresh concrete, quality control of fresh concrete. If concrete is not homogeneous and does not have workability suitable for types of work to be done such as transportation, placement and compaction, poor placeability or defects might result. Workability of fresh concrete can be judged. Workability of fresh concrete can be judged to some extent by observing the state of concrete during unloading and placement. Even if tests are not conducted frequently, quality fluctuates considerably. Tests should be conducted on an as required basis to identify cause of problems and resort to early corrective measures. It's also desirable that frequency of quality control checks be increased until quality becomes stable. Slump, air content, temperature of concrete. Slump. Slump test is conducted to ensure workability of concrete. Slump test is conducted to ensure workability of concrete as well as homogeneity of concrete. It is necessary to check production of concrete with given material, particle size, distribution of aggregate, surface moisture content of aggregate, and so on with change when change of slump is acknowledged. Slump cone test can also provide an indicator of quality of fresh concrete. Since slump changes with time after finish of mixing, it is necessary to take into account difference in time in which slump test and actual placement of fresh concrete are conducted. Air content. Change in air content results in change of workability. Change in air content results in change of workability, strength and durability. In order to ensure air content in fresh concrete, air content test is conducted. Since change in air content results in change in slump and cause should be clarified. Change in air content results in change in slump. Cause should be clarified. In case of take concrete and change in air contents are taken into account. Temperature of concrete have influences on slump, air content, thermal temperature due to hydration, development of strength and properties of hardened concrete. It's important item for quality control for construction of mass concrete, cold weather concrete and hot weather concrete. Besides, it's necessary to check temperature of concrete during curing. Quality control of hardened concrete. Quality control of hardened concrete. Because time required to get results of concrete, strength tests conducted to test quality of hardened concrete is too long. Those tests are usually not suitable for use in quality control. It's more rational, therefore, to spend effort in quality control of material and production. When rarely produced concrete is used during a certain period of time after production is started, or during a period when air temperature changes considerably, it is good practice to check on changes in compressive strength. Quality control during construction. Quality control during construction. Quality control during construction. If quality control during construction should be checked whether each type of construction work in progress, such as work related to concrete, reinforcement and formwork and false work agrees. In quality control during construction, it should be checked whether each type of construction work in progress, such as work related to concrete, reinforcement and formwork and false work agrees with plan, and if necessary, method being used should be changed to more effective methods so that concreting work can be carried out smoothly. At construction stage, At construction stage, it is important to check whether each type of construction work in progress, such as work related to concrete, reinforcement and formwork, and false work, agrees with plan so as to carry out concreting work smoothly. Attain, you can say, at construction stage, it is important to check whether each type of construction work in progress, such as work related to concrete, reinforcement and formwork and false work, agree with plan so as to carry out concreting work smoothly, attain required quality and complete work by planned date. It's often not possible to proceed with work as planned because of, for example, changing quality of concrete, changing environmental conditions, differences in experience of workers, and differences in performance of equipment. It's needed to give workers appropriate instructions as to specific methods to be used for further improvement of method used. Quality control in preparation. Since weather during construction is always in a state of change, important to check on weather forecasts in advance and make preparation such as rescheduling work to be done on day or during coming week, or taking rain protection measures. Adequate preparation of each type of work minimizes problems encountered during construction. Quality control in concreting work. Quality control in concreting work. If methods used for transportation, placement, compaction, finishing and curing are not appropriate, it's difficult to construct a concrete structure of required quality. It's important therefore to fully understand points to remember described in. It's difficult to construct a concrete structure of required quality. It's important therefore to fully understand point of we can say it's important therefore to fully understand points to remember described in chapters and check whether the method described there appropriate on basis of construction plan and quality control plan. In quality control for each type of work, basic rule is to control facilities and equipment used, staffing and construction methods prior to placement of concrete. It must be carefully ascertained that reinforcement and formwork and false work have been placed and constructed as planned. Transportation to site. Transportation times of agitator truck should be checked to keep given time until finish of placement. Transportation time of agitator truck should be checked to keep given time until finish of placement of concrete, so that placing concrete can be continued. Number of agitator trucks based on amount of placing concrete and its placing rate should be determined, and transportation plan for these agitator trucks should be prepared before actual construction starts. Schedules of managing transport should be prepared, in which planned and actual time for shipping, arrival, finishing of discharge and number of agitator trucks based on the amount of placing concrete and its placing rate should be determined, and transportation plan for these agitator trucks should be prepared before actual construction. Schedule of organizing transportation should be prepared in which planned and actual time of shipping, arrival, finishing, discharge and tests. Estimated time arrival and interval, estimated time interval, number of agitator trucks, amount of loading, and you can say accumulation. Either the quality we can say either quality control or inspection, amount of loading and accumulation, either quality control or inspection of acceptance are indicated. In addition, it's good practice to make close contact with the person in charge of quality control at factories and at placing site. These practices make it easier in placing concrete continuously. Transportation within sight. Transportation within sight. It is necessary to manage types of transportation, equipment needed, its form and capacity, arrangement of personnel and method of transportation according to prepared plan within sight. Concrete pump is usually required for transportation within sight, and concrete pumping works shall be left management to specialist. Concrete pump is usually required for site. Concrete pumping works should be left to management of specialist. However, it is important that person in charge of quality control should advise properly method of pumping by considering quality of concrete, transportation using agitator trucks, compaction and pressure to the formwork. Placement and compaction in placing and compacting concrete. Order of placement, placement rate and its height. Interval of layered concrete. Position of joints, height of compaction, compacting and method of compaction are required to be checked. Proper countermeasures should be taken when actual workability is reduced. Through reduce the period of time for placement is within allowable time. It is necessary to pin out compaction time and this interval since effectiveness of compacting with vibration may be different by conditions of concrete and reinforcement arrangements. Finishing concrete. In finishing concrete, number of finishing actions, period and methods of finishing are managed if they follow initial planning. Appropriate period of finishing may be varied depending on weather conditions and ability of workers. When finishing time of placing concrete is delayed, finishing actions may be carried out I say finishing. In finishing concrete, number of finishing actions, period and methods of finishing are managed if they follow the initial planning. Appropriate period of finishing may be varied depending on weather conditions and ability of workers. When finishing time of placing concrete is delayed, finishing actions may be carried out during night. Subsidence cracks and separation occurs by finishing with bleeding water. It is necessary to manage schedule when finishing time of placing concrete is delayed. Finishing action may be carried out during night. Subsidence, cracks, and separation occur by finishing with bleeding water. It is necessary to manage schedule of completion of finishing and its methods. Curing. Equipment, workers, arrangement, and methods required to be checked if they follow to initial planning. For wet curing, a person in charge of quality control must understand procedures of curing to avoid improper curing. Inadequate wet curing may result from improper curing with sprinkling water. Sheet and mat at locations of projection or enforcement. Inadequate wet curing So we can say with adequate wet curing, quality of concrete is reduced as compared with that of water cured. Says inadequate wet curing may result from improper curing and sprinkling water. Sheet and mat at locations of projection of reinforcement. With inadequate wet curing, quality of concrete is reduced as compared with that of water cured concrete. For strength and durability of structure, quality control of curing is important. I have to just read this for a couple of minutes, and I think we'll be back. Okay. Sorry gentlemen, a little late, but it's no problem. Curing, we have to continue. It's very important item. And we have to see curing equipment. Curing equipment workers, curing equipment, curing equipments. Workers' arrangement and methods need be checked if they follow to initial planning. For wet curing, a person in charge of quality control must understand procedures of curing to avoid improper curing. Inadequate wet curing may result from improper curing with sprinkling water, sheet and mat at locations of projection of reinforcements. With inadequate wet curing, quality of concrete is reduced as compared to that of water-cured concretes. For strength and durability of structure, quality control of curing is important. Steelworks, following are important notices for steelworks. They also can be applied to quality control for other types of reinforcement. Drawing of bar arrangement, planning, acceptance and storage. Steelworks, drawing of bar arrangement, types, diameter and length of steel cover and spacing, bending shape and position of anchor and joints are checked if they follow drawings. It is necessary to check if supportive and temporal bars are required. There are positions at which bar is not arranged and accordance with drawing, and there mistakes occur in drawings. Planning, a standard procedure for planning of bar and personnel, for considering ability, arrangement, storage, site, within construction site and selection of equipment for bending bars is prepared. By considering load on spacer, necessary spacers. By considering load on spacer, necessary spaces of bar arrangement need be secured. By considering load on spacer, necessary spaces of bar arrangement need be secured. A standard procedure for planning of bar and personnel for considering ability, arrangement, storage site within construction site and selection of equipment for bending bar is prepared. By considering load on space or necessary spaces of bar arrangement need be secured. Acceptance and storage, types, diameter, length and number of bars required are recognized. Checked if length is enough for transportation and no use duration processing is reviewed. By ensuring if transported steel are ordered once at acceptance and they are storage so as to prevent corrosion and dirt. Drawing of processing, content of standard procedure. Drawing of processing, content of standard procedure and specification of a slice processing machine are ensured Types and numbers of bars after processing and accuracy of processing are needed. Be checked and controlling within own target values reduces risk of failure in inspection. Fabrication. Spacer, band wires, space of formwork, given position, and interval of center, effective depth, cover, anchor length, position of bending, position length and method of joint, and treatment for compressive steel and weathering are checked. Checks must be completed before placing concrete. Allowable error in target of control, which is determined based on types and importance of structure, is set up with own values more severe than those employed at inspection, so that risk for failure in inspection is reduced. Refabrication of steel requires a great deal of workers, and hence it is advisable to ensure each step in fabrication to avoid mistakes. When time is elapsed after fabrication corrosion, contacting mud and oil and displacement of bar arrangement effects, it is advisable to clean steel and ensure accuracy of fabrication before placing concrete. Formwork and shoring. Formwork and shoring. Important notices from formwork and shoring. Important notices for formwork and shoring. Calculation and control. That is calculation and control. Other one is sufficient strength and safety against expected load are required for formwork and shoring. A person in charge of quality control ensures results of calculation, formwork and shoring. Attention is paid for expectation of load, since lateral pressure and external load that is beyond initial expectation may occur. By considering minimum slump at placement of concrete and change in slump with time, target slump is determined at discharge of fresh concrete in specification. Increase in lateral pressure due to larger slump, then minimum slump specified must be taken into account. It's safe to consider change in rate of placing and temperature of concrete. Drying and construction. Construction is ensured if it follows the drying and procedure. Construction accuracy for formwork and shoring is determined so as to obtain a given position, shape and size of structure. It is noticed that accumulated error associated with each works must be still within allowable errors. Before reuse of formwork and shoring, it is checked if degradation is not influential to concrete and separation agents are removed. Before reuse of formwork and shoring, it is checked if degradation is not influential to concrete and separation agents are removed. When these care are not properly taken into account, surface concrete contacted with, when these care are not properly taken into account, this is, you can say, before reuse of formwork and shoring is checked if degradation is not influential to concrete and separation agents are removed. When these cases are not properly taken into account, surface concrete contacted with formwork is affected. Corrosion of steel bars used as a fastened material and improper welding wires may result in failure of formwork. This must be paid attention not to occur, and all this is called remaking of plates, remaking of formwork. Making is first, then you can say deshuttering means breaking, and then remaking, and that is for purpose of repetition of plywood or planks, whatever we have, and also backing, you can say maybe timber backs, scantlings or patterns may be used many number of times. Control in use during placing concrete, leakage of paste and mortar, from gap, widening, movement, slant and subsistence of formwork and shoring, softening in joints, floating, cylindrical, mold, need be checked to prevent accident and resort to whatever actions if it taking place. Workers in charge of not only concrete works but also formwork and shoring works are placed during placing concrete. As we have said, carpenters are required, steel fixers are required. It says workers in charge of not only concrete works but also formwork and shoring works are placed during placing concrete. Communication with a person in charge of quality control for concrete works should be made to ensure use of concrete with expected slump rate of placement and temperature, which are assumed in calculation for formwork and shoring. Removal time by considering temperature, conditions of structures and formation of thermal cracks, formwork and shoring are removed. Strength development is slow in low temperature and displacement. Cracks may occur when bottom plate formworks used in decks are removed. Quality control of concrete structures. Until a concrete structure is taken out by owner, structure shall be kept under control so that a concrete structure of required quality can be delivered to owner. Passing owner's inspection of concrete structure can be made easier by checking during construction on state of concrete surfaces, positions and dimensions of concrete members, quality of concrete in structure and concrete cover. For example, cracking might be caused by long-term temperature changes, drying, shrinkage or changes in state of stress in course of construction, even if there was no single visible crack immediately after completion of structure. A concrete structure may also be affected by environmental factors such as natural phenomena including typhoons and earthquakes, deformation of surrounding ground